You guys had homework from 3.6, is that right? 3.6? So in 3.6, starting with number 21, if you attend lecture and study, you succeed. And in the directions, it wants you to use De Morgan's law to write a statement that is equivalent to the given statement. Okay, so first of all, we need to, what might be easiest is if you translate this to symbolic form and pick out the key words that you see in this sentence. And, if. Okay, so and if are your key words. And so once you identify those connectors, then it makes it a lot easier to identify your simple statements. So your first simple statement, P, would be what? You attend lecture. Good. Q, you study. Good. Somebody said the word you. It's important to make it a complete sentence. And then the last one, you succeed. Now, before you write a third letter, always double check to see if this is the negation of either of the first two. Okay, when you look, not the negation. Okay, totally different statement. So then go ahead and pick a third letter, you succeed. But sometimes that can happen, so you want to make sure you don't just automatically throw a third letter in there. Make sure it's not the negation of something you already did. All right, so we have, if you attend lecture and study, you succeed. So, and notice that there's a comma also, which now the if means that we have an if-then. They just chose not to use the word then. And so the if part of our if-then is what? The P and Q. It's the whole and statement. Okay, so that whole and statement is the if part, P and Q. And because that comma is there, that means that this whole thing is one group in parentheses. That's the if part. And then the then part is R. Okay, so that's how that translates symbolically. Now, the direction said use De Morgan's law to write something that's equivalent to this. And this doesn't look like something you would use De Morgan's law on. You don't have a negation symbol, and you have an if-then arrow in there. Okay, so before you think De Morgan's law, think what's another way of writing an equivalent statement to this. And this is where all those other equivalent statements come in. And you got to remember all the things that we've talked about. So first of all, notice that there's an if-then. If P, then Q. We could write that equivalently as what? As there's a couple different things that we can do to write it in an equivalent way. So if somebody can come up with one of them. Yes, ma'am? Well, don't think about the words. Think symbolically. If you had an if-then statement, what's one of the patterns that we learn to write it equivalently? P and not Q would be the negation of it, so not the equivalent. I heard something else over here? No, P and Q is totally different. And so again, just look at this. Forget about the problem that we're working on right here. Yes? Negate both sides and reverse the order, right. So if not Q, then not P. So that's one way. And that is called the contrapositive. Good, contrapositive. Okay, so we could rewrite this as the contrapositive, and that would be equivalent. And watch what happens. So if I reverse both sides of the if-then, I've got if not R, then not this entire parentheses. Now you have something that you can use De Morgan's law on. Right, so now do De Morgan's law on the second part. So distribute that negation and flip. And you have if not R, then not P or not Q. Now we still have to keep this in parentheses to show that's the entire then statement. And so there's one way we can write our equivalent statement, and we use De Morgan's law in the process. And so we've got if not R, if you don't succeed, or if you didn't succeed, however you want to put that, then you didn't attend lecture, or you didn't study. That's fine. If you don't have to put it symbolically, then that's okay. But keep in mind that if it's a non-multiple choice problem, you're supposed to show me something of work. And so if you do it all in your head and you get it wrong, there's no partial credit. And if you did it right and you have nothing to show for me, you'll still get a point marked off for not showing any work. But on the multiple choice, I'm not giving partial credit. You're just choosing your answer, so that doesn't matter. Okay. Not on the multiple choice. So, because I'm not looking at work for the multiple choice. And the non-multiple choice, it's going to be as much as, 5 questions on there. Now, if it's straight translate the symbols to words, then there's no, work to be shown there. You're just translating, or vice versa. But you would still have to identify your simple statements. So see, there is a little bit of work to do there, okay? And if it's as simple as just changing it to the contrapositive, a simple statement, an if-then to a contrapositive, okay, that's not as complicated. This I would see a little bit more difficult to be able to see you guys just do it all from scratch without doing something on paper. Okay, number 25. Same question here. Use De Morgan's law to write an equivalent statement. And notice that you again have an if-then in here. So really what they want you to do is look at the if-then first and then see if De Morgan's law can simplify it at all. So similar to what we did before, what can we do to write an if-then in an equivalent way? Negate both sides and reverse. Good. So it's called the what? Contrapositive. So I'm going to negate this entire parentheses and put it up front, and then have a not P at the end. But now I can use De Morgan's law on this parentheses because it's an or statement. And so I get not Q, and the negation of not R is R. Still put it in parentheses, leading to not P. And that was in symbolic form, so that's how you would leave it. Okay, number 27. It says write the negation. I'm going to Seattle or San Francisco. So what keyword do you see here? Or. So P stands for I'm going to Seattle. And Q stands for not just San Francisco. I'm going to San Francisco. Okay, so there's 2 ways that I can write the negation of this. I'm going to show it symbolically first to make sure everybody follows the pattern, and then we'll write it out in words. But right now, I have P or Q. And so one way to write the negation would just to put that symbol in front of it. And that in words, that would be, it is not true that I'm going to Seattle or San Francisco. But that's never going to be your choice in the multiple choice, okay? So the other way to write this in an equivalent manner is to use De Morgan's law.
Is that what the 3 things mean?
The 3 things mean equivalent to, yeah. Instead of equal, equivalent to. So distribute that negation and change that or to and. And so they're looking for, I'm not going to Seattle, and I'm not going to San Fran. Okay, number 39. Okay, so again, they want you to write the negation of this. So the initial way you can look at it is saying, take the whole thing and put it in parentheses and put a negation in front of it. Okay, and it is not true that. But they also want you to simplify this as much as possible. So notice that we have an and statement inside the bigger parentheses. So when you distribute, you're distributing it like this, to the P and to the parentheses, and then flipping that and over. So you have not P and not the entire parentheses. But notice now you have another negation outside parentheses. Is that what you were going to ask?
I was just wondering, what if P was on the opposite side of the parentheses? Would that be wrong? Or?
You mean if this was in reverse and the Q or R came first?
Yeah.
Either way, then this would be reversed. But
Okay.
try to keep it in the same order that they gave it to you to stay consistent with what they're looking for. Okay, but now we have another negation outside of parentheses, so now we can do De Morgan's law again. And so we have not P and then, oops, I never flipped this. Nobody said anything. Okay, this should be an or, and this should be an or. Okay, so that needed to flip right here. Okay, so got to flip when you apply De Morgan's law. Okay, so then here I get not Q, and this or becomes an and, not R. But note that the right-hand side was already in parentheses to begin with, so we got to keep parentheses around that. Yes? So that is your final answer. So for the next couple problems, it wants you to determine if any of the 3 given statements are equivalent. You may use information about conditional statements, converse, inverse, contrapositive, De Morgan's law, or truth tables. In other words, they're saying take everything that you have learned from Chapter 3 and apply it to these statements. So starting with number 43. So statement A, if the grass turns yellow, you did not use fertilizer or water. B, if you use fertilizer and water, the grass will not turn yellow. And C, if the grass does not turn yellow, you use fertilizer and water. Okay, it might help to list all of the equivalent things that we've learned so far to help us with these types of problems. And again, if these are things that you have trouble remembering, then these are the types of things that you probably want to put on your note card for the test. Yes, you're allowed to put stuff on both sides of the note card. Okay, so here. So some of the things that we've learned, okay, we've already talked about the contrapositive. And then we also learned of an or statement. What's an equivalent way that you can write an or statement? Nope. There's no negation in there. So it changes to an if-then. Yeah, there's a not. So let me help you guys out. Okay, obviously this is one you want to put on your note card. All right, if not P, then Q. Because remember, you're doing one or the other or both. So if you don't do one of them, you have to do the other. But you can also choose to start with the Q. If not Q, then P. Okay, if you don't do one of them, then you have to do the other. An or statement can change to either one of these. And also notice that these are contrapositives of each other, so that's another reason why it works. And then we've got De Morgan's Law. And then we also have the negation of a conditional statement. Okay, if you're trying to negate an if-then, then how do you write it? So remember, the only time an if-then is false is when the first part is true and the second part is false. So if you keep the first part the same, or true, and the other one's false, then there's your negation of an if-then. P and not Q. So no, this is not De Morgan's Law. This is if you're trying to negate an if-then statement. Then you leave the if part the same, use the word and, negate the then part. And the reason it works is because that's the only thing that makes an if-then false. If it is a true statement, then the negation would be false, P and not Q. Again, if it's not one that you've gotten down, then definitely put that on your note card. And obviously, a lot of you haven't gotten that one down yet. Okay, so these are the main things that you need to remember in order to make these types of problems easier. So if we take a look, for me it helps to translate these symbolically first because most likely on your note card you're going to have these things in symbolic form. So for the first one, the key words we have are if, or, and then we also have a not and a comma. Good. Okay, so our simple statements here, P can stand for the grass turns yellow. Q, you use fertilizer. and R, you use water. Good. Okay, so for this one, we have if P, then not Q, or not R, because you did not use fertilizer or water, so that means you didn't use both. And then we need parentheses around the second part. Okay, this next one, the key words are if, and, not, and the comma. Okay, so if you use fertilizer and water, so those are what letters? Nope, not P. Q and R, and it's in parentheses because that's the entire if with the comma there. Then the grass will not turn yellow. Not P. And then the last one, the key words, if, not, and a comma. Okay. So if the grass does not turn yellow, so if not P, then you use fertilizer and water. Q and R. Okay, so comparing these things symbolically, do they match any of the, do you see any possible patterns from the patterns that you already know? Okay, so notice that A and B we have some reversal, so we could maybe check to see if that's a contrapositive. And so if you take this, it's probably easier to use the one that has the least amount of negations in it and reverse that and see if you get the same thing over here. So if you take this one and reverse it, then that is equivalent to starting out with a P, then we're negating this entire parentheses. But what happens when we negate a parentheses with an and? Right, we're going to distribute, and so that gives us P, then not Q, and not R, which, yes, is the first one. See how it completely matches the first one. So we know A and B are equivalent. And now take a look at what we did. Here, let me get a highlighter here. Compare this one and this one. The negations are the difference. And notice that from here and here, P has been negated from the first to the second. And here, the negation came off. So that's the same as negating it. So all that happened was we negated both sides and nothing else. And what is that called? The inverse. And is the inverse equivalent to the original? Right. If you negate both sides only, then that is not equivalent. Okay, so this is the inverse, which is not equivalent. So the converse and the inverse are not equivalent to the original if-then statement. The converse and the inverse are only equivalent to each other, but not to the original if-then. Okay, so when you negate both sides, that's not equivalent, so therefore this one's not equivalent, and our answer is A and B are the only ones that are equivalent to each other. Okay, so you see how I used the rules to figure out which ones were equivalent. Worst case scenario, you're not sure, what can you do? Truth table, truth table. Do a truth table for every single one, and only the ones with the last columns that match are your equivalent statements. And this, if you did a truth table for this, you'd find that it had a different last column, and you know for sure that it didn't. Now, truth tables would take a while because it's 3 letters. So if you can know the rules, then that should save you some time. Okay, 45. A and B. A and B was your answer. I'm leaving and Tom is relieved or Sue is relieved. B, I'm leaving, and it is false that Tom and Sue are not relieved. If I'm leaving, then Tom is relieved or Sue is relieved. Okay, so in the first one, keywords. And. Oh, that's supposed to be an or, isn't it? Okay. So that's supposed to be an or. I wrote it down wrong. And the comma. Good. Okay, so P can stand for I'm leaving. Q, Tom is relieved. R, Sue is relieved. Because none of these are negations of each other. So I have three simple statements. Okay, so I'm starting out with P and Q or R. And I need parentheses around the second part because there's a comma right next to the and, so that's where it splits it. Okay, the second statement, P and, oh, what other keywords do we have? I forgot to do that part. Okay, not. It is false that. And. Okay, so P and, it is false that means I need a negation outside parentheses. So that takes care of the comma as well. It's all in one spot. Okay, so Tom and Sue are not relieved. So that means I have a not Q and not R. And then the last one, if I'm leaving, so if P, and I also have a then, anything else? Or, and that's it, right? Okay, and the comma. So if P, then Q or R. And I need parentheses around the right-hand side. No, the if-then makes the arrow, but the comma reinforces that I need parentheses around the right-hand side of the arrow, because the comma split it right here. Okay, so the most obvious thing I see is in the second statement, and I see that I can use De Morgan's law right here because I have a negation outside parentheses. So if I use De Morgan's law, notice I get P and the negation of not Q gives me Q, the and turns to or, and the negation of not R, R. And so still keep parentheses around the right-hand side. And notice that it looks exactly like A. So far I know that A and B are the same. And notice I've got an and statement is what I'm looking at for both of them. The if-then only changes to an and statement if I have a negation outside of it. Okay, so I can't do that. I could do contrapositive, but that's still going to leave it as an if-then statement. And the only other thing that's equivalent is I can change an if-then to an or right here. So if I take this pattern for if-then, that means I need the opposite of the if. Okay, so the opposite of this would be not P, or keep the second part the same. The then part stays the same. And that still does not look like what we already have. See, this needs to be an and that needs to be a regular P. So this third one is not equivalent. If you wanted to check for sure, you could do a truth table and compare it to the original A statement. Okay, last one, number 51. It's write the negation of this statement. Okay, so the negation of this statement means I'm putting the whole thing in parentheses and putting a negation outside of it. But now you need to simplify it. So we're mainly negating an if-then. That's what the main symbol is here. And so we just talked about that. How do you negate an if-then? An and, good. So I'm going to change this to an and. The if part, does that stay the same or does it change? The same. The then part, same or negate? Negate. But now notice that I have a negation outside parentheses. So De Morgan's law on that second part, which leaves us with not R or S, but keep that in parentheses. And so there's your final answer. All I can say is practice, practice, practice. The more you do these, the more familiar you're going to become with the rules.
So the rules for negation of the if-then is an and.
Right. So it's this one right here. And then after I applied that rule, then I saw I had a negation outside parentheses of an and statement. So, the and was inside there, so that's what told me De Morgan's law. And remember, De Morgan's law is only used when inside the parentheses you see an and or an or. If there's any other symbol inside that parentheses, then you're not using De Morgan's law. It doesn't work.